I've got a magnet here, a big fat circular magnet. It's a ring-shaped magnet, rather like the sellotape, so it goes round. This is a tiny little compass needle, so this seems to be pointing upwards, and it moves across, it goes horizontal, and then it goes downwards out the other side. So there's a magnetic field coming out. I've got another little magnet. This is, again, a ring magnet. On the top, you can see the magnetic field is pointing upwards, and on the bottom it's going the other way. So now, if I bring this downwards, there's a repulsion, and you can feel as you bring it down, there's a repulsion between these two. It's as though I have here a really big magnet, and what I want to do is place this big magnet over the center, and if I get it over the center, you can see it will start to float because of the repulsion between this magnetic pole and the magnetic pole in the base. So as I lift this up, it will slide down, and it wants to stay about that height. This is a really strong magnet, so it's probably 2 inches or more above. So now what I want to do is get this to be floating above there. And I can't do that normally because it wants to turn that way. So I try and get it to go there, and it will fall down. So the trick is to spin it, because if you spin it, it has a persistence. It wants to stay upright like a little spinning top. So the object is to take this thing and put it in a space above there, spinning round so it doesn't fall down. And you do that in 2 steps. The first step is to spin it on here. You see how it wants to repel against there. And of course I can go for half an hour doing this. Take 57, take 972, until I get one that works, and then I lift it up bit by bit to the point where it just comes up, and then it starts to float in the air. And if I got this level, it will stay there for a nice length of time. This is not held up. Oh, I should have balanced it a bit better. And it's more or less level there. I can pass a ring through it, either direction. Nothing is supporting it. No magic is involved, no animals were killed. And there it floats for about 1.5 minutes, and I don't know what to say that will keep you amused for that length of time. It starts to precess when it slows down because of the friction of the air. The rotation rate goes down a little bit. So here it's spinning around maybe at 25 rotations per second, and it slows down bit by bit, and you can feel after a while that as it slows down, the direction it's pointing starts to waggle around a little bit, and then about 10 seconds after that, it plummets down to the ground. Well, this is the point where we find out whether this is all a dream or not. It's just waggling so much that I'm sure, yes, there it is. Yeah, it's a mixture of repulsion and gyroscopic motion, but the paper that came out to explain it all was by Sir Michael Berry, who is one of the leading theoretical physicists of his generation. And he loves all these toys. He would go and analyse them in gory detail. The idea of having a magnet, a rotating magnet, well no, a spinning magnet, it has analogies with protons and neutrons, which can be in traps, or atomic particles, which can be in magnetic traps. So it is used, but not quite in this toy-like form. I found I'm addicted to this.